Okay, so geometric is going to be the sum of the terms in a geometric sequence. So this idea of series shouldn't be new to you because we talked about series before, right? We know it's a series, whether it's arithmetic or geometric, if it's separated by plus or minus signs. Now, it can be plus or minus signs in a geometric, depending on if our R value is a positive number or a negative number. So if we add these on the calculator, we get 1,093. This is okay for a limited number of terms. So the same idea that if we're summing only a couple terms, easy to do. As soon as we want to sum a lot. Now for the sake of time, I'm not going to prove the formulas to you. If you want the proof, you can find it on page 48 of your textbook. Okay? But we don't have much time, so I'm going to say if you like the proofs of those and want to see how they're developed, look at the textbook. I have a feeling that most of you won't, and that's okay. The key here is understanding the formula. So what's the difference between the two? Well, in this very first one here, you can see you need to know your R value. Of course, we both need to know R, our common ratio in both. You need to know your number of terms in the first one, and you need to know your first term. In the second one, you don't need to know your number of terms, but you just need to know your last term. Okay? So this formula is for if you know your last term, where the first one is you know the number of terms. Okay, so there's two formulas. They're on your formula sheet, and we're not going to prove them. Okay? Determine the sum of the first 10 terms of a geometric sequence here, or series. So if they're telling us 10 terms, what does that 10 stand for? The n. N is 10. Okay, term 1. Four. What's our common ratio? What are we multiplying by each time? 3. Good. I can make this larger if it's hard to see. Okay, 3. So, if we know the number of terms, we don't know the last term, which formula will we use? The first one, right. So we want to use S of n equals term 1 times r to the power of n minus 1 all over r minus 1. Okay, so we're going to use that formula because we know the number of terms and we don't know the last term. So subbing this in, term 1 is 4 times, so brackets, r is 3 to the power of n, which is 10, minus 1. Now the minus 1 is not in part of the exponent. Okay, all divided by your r minus 1. Now what's really important is when you enter this in your calculator, you have to make sure there's brackets around your denominator, else you will not get the right answer. Or just make it a 2, and then you're safe. Okay, so grabbing our calculators, 4 bracket 3 to the power of 10 minus 1 divided by bracket 3 minus 1. Or again, you could just write 2, and then you're safe. Okay, so make sure you can type that in and get the same answer of 118,096. Okay. So this is second example here. That's just what we know. Determine the sum of this series, geometric series. First term is 4. What's the common ratio this time? What are we multiplying by? Is it 4 or negative 4? Negative 4. Okay, our common ratio is negative 4. And that's why the sign keeps switching. Common ratio is negative 4. We don't know our number of terms, but what do we know? The last term. What's the last term? Negative 65,536. Good. So we can go straight to using our second formula, okay, where the S of n is r to the times our last term minus the first term all over r minus 1. Okay. So we don't know our number of terms, but that's okay. Common ratio is -4. The last term, so common ratio times the last term minus the first term, which is +4, all over -4 minus 1. And again, it's really important we wrap our numerator and our denominator in brackets to be safe. And especially in this formula, because there's that subtraction stuff going on in the numerator, and it's not just multiplication. Kind of already had brackets in the first formula here. It was just multiplication, we already had brackets kind of built in. We didn't have to really wrap this, because this is 4 times, and multiplication and division, those are interchangeable in BEDMAS. But on this one, because we have addition, subtraction going on here, well, subtraction with the -4, we have to wrap this in brackets in our calculator, else it will not work out. Unless you just solve the numerator and then divide by 3. Then you're safe. Okay? So type this in, make sure you can get the same answer. So times 6, and then take away 4, divided by bracket. Now some of you actually have a feature on your calculators, if you have an updated calculator and the software is updated, which I will let you know if I haven't told you, you can update your software on your calculators by plugging it in and going to the TI website. There is a way for some of you to actually make that fraction. I think it's second y equals, I can't remember, but some of you are actually has like a numerator over denominator option. And if you have that, and I can help you find it later, then you're golden, because you're not going to make those mistakes with the division. And so you should use that. Yeah. Okay. Maybe we'll have a day where we can try to use my computer and update your guys' software on your calculator so that you're all up to date. All right, did you get the same thing? -52,428. Okay, that's what you should get. If not, something went wrong. And you want to make sure that you can type these in. Because the worst thing is if you're got the right work, but can't get it right on your calculator. That's heartbreaking. Especially on a test or a quiz. Can we move on? Yeah? Whew, so pithy. Oh, the chess question. May come back to the chess question. Love the chess. Let's go back to the chess question. Let's go into an example 4. Okay. A car's value depreciates on an average of 15% per year. Ooh. The car's original value is $35,000. Determine the value of the car after 5 years. Okay. So, my question for you, okay, let's figure out this. What's your T1? Okay, we can all agree that that's 35,000. What's your common ratio? Is it 0.15? So, if we're talking about the value of a car, how much will it be worth? How would you get how much it's worth next year if it's going down by 15%? You'd multiply it by, I think I heard it. Okay, so if I multiply it by 0.15, does that give me the value of the car next year? Or is that how much it's decreased? That's how much it's decreased. Okay, so how would I get the value of what the car is worth next year? So I could subtract it, yeah? What if I told you there's an easier way? What percent of the value remains? So if it's losing 15%, what percent remains? 85% of the value remains. So an easier way to get the value is to multiply by what percent remains. Oops, that's not even close. Let's insert a decimal in there. There you go, 29,000. So a lot easier, right? So when something's going down by 15%, to get our R value, we need to think, okay, what percent actually remains? And so we're retaining 85% of its value every year. That's our common ratio. Okay, do you want to solve the rest? So after 5 years, so this would be after 1 year, right? Right, would you agree with that? Was 35,000 times 0.85, which was, how much was that equal to? 29,750. That's how much it's worth after 1 year. So after 2 years, after 3 years, after 4 years, after 5 years. So what term value are we looking for? Term number? It's going to be term 6. Be careful of that because time starts at 0, but terms start at 1. And so when it's saying 5 years, that's the 6th term because years always start at 0. So 35,000 would be like year 0 after 1 year, after 2, 3, 4, 5. And so you want to kind of like lay out that pattern so you can figure out, is my end value the same as the number of years or is it different? And in this case, it's different. It's 1 more than that. So we're looking for term 6. All right, so it's geometric, so it's just a simple, simple. We threw this one, even though it's a geometric sequence question, I threw it in there into this lesson because I wanted to give you an example with depreciation. So even though it's not a series, but that's okay. So this one is not, we're not adding our terms. It's just a sequence formula. Oh, what did I do here? I'm supposed to, huh? Power of 6 minus 1, so power of 5. So $15,529.69. Get the same thing? Yeah? No? Yeah? Thank you. Okay. 69. I think I rounded to 60. Yeah. Okay. We'll go back to that chess question later. Let's go to example 5. It's another bouncy ball question. Showing up again. Maybe it'll show up on your test. Who knows? Or midterm. A bouncy ball is dropped from a height of 10 meters. After each bounce, this ball rebounds to 70% of its original height on the previous bounce. Determine the total vertical distance the ball will have traveled once it hit the ground for the 8th time. Okay, there's 2 ways to set this up. First thing though is we want to draw a picture, no matter what. So again, we want to kind of draw that large diagram that we did before, over-exaggerate it. Okay, so here's bounce 1. It's at 10 meters, it falls. Of course, it's actually falling vertically, but I'm just spreading it out so we can kind of get an idea of where's my term 1, what term am I looking for. And it wants the total vertical distance the ball will have traveled once it hit the ground for the 8th time. So let's draw 8 bounces. Okay, so it says it rebounds 70% of its original height. So if it falls 10 meters, what's going to be the height after the first bounce? 7, because 70% of 10 is 7. So this would be 7 meters. This would be 7 meters, right? Goes up 7 and then down 7. And then you could figure out, so if you could actually calculate each one of these and go from there. Now it wants the total vertical distance. So it wants the up and the down, all of them. We want all these terms together. We want to sum them. So this is a series. So depending on how we set this up, you have two options. Okay, we can set this up where term 1 is the 10. Or we can set it up where term 1 is 7. Okay, I'm going to show you both. If I set it up where term 1 is 7, let me show you what we do. So if we're going to do term 1 as 7, if that's the case, let's use a little highlighter here. This would be term 1, okay? If we're setting it up this way. Oh, that is not what I want. Term 1, term 2, term 3, 4, 5, 6, 7. Okay, so I'm saying these are what we're finding. Okay, so I want to find the sum of those 7 terms. So now will get me all the time it rebounds up. All the vertical distances added together that it rebounds up. So term 1 is 7. I want to find n equals 7. I'm going to use n as 7 in that case. And I want to find the sum of the first 7 terms. Now that's not going to give me my total vertical distance. That's going to give me part of it. How am I going to get the total vertical distance? So would you agree that when it goes up 7, it also comes down? Yeah. So what can I do to once I find the sum of those that I've highlighted, what can I do to them to get the other side? Multiply by 2. Yeah. So the total vertical distance would be 2 times S7, but would that be all the total vertical distance, or do we have to remember somebody? The 15. So in order to remember the 15, not 15, 10. The 10, right? We didn't include the 10, so we need to add 10. So that's how we're going to get the total vertical distance. Once we find the sum of the first 7 terms, or 7, right? 7 after bounce heights. We're going to add those all together as 7. Then we can times it by 2. That would give me the downward part. And then I need to remember to add on the 10 because I didn't use this as my first term, and so I need to include him. Okay, so we know our first term, we know n. What else do we know? Common ratio is 0.7. So we're going to use that first formula for the sum. So that was, let me just erase S7. So we don't know our last term. So we're going to use, which was, I don't have that one memorized. A times, not A. I used to always use A for term 1. Bad habits. Term 1 times r to the power of n minus 1 all over r minus 1. Okay, so we're going to start by finding the sum of the first 7 terms. Term 1 is 7, was our first term we made, times 0.7 to the power of 7, lots of 7s here, yeah, minus 1 all over 0.7 minus 1. And again, you need to put those brackets in your calculator when you sub that in. Divided by bracket 0.7 minus 1. Okay, 21.41 approximately. But we're not done. Did you get the same thing? If you typed it in, yeah? So to get our total vertical, it would be twice that plus the original 10 that we fell. So times 2 and then plus 10. Did it say any rounding instructions? Nearest 10th? No, it didn't, hey? Guess your nearest 10th. So that is 52.8. Okay? 52.8 meters. Now, there's another way to set up this formula, and I want to show you that as well. And that's if you use your term 1 equal to the 10. Okay? So if you want to make term 1 equal to 10, that's totally fine. So if we did that, 1, 2, 3, 4, 5, 6, 7, 8, we need to find 8 terms, the sum of the 8 terms. Okay, so n equals 8, common ratio is still 0.7. The only thing is our total vertical distance, it's very similar formula. It would be 2 times the sum of the 8 terms, because for each green, there's a yellow, except for in the first case. And so when we double this, what happens is we actually end up including, I'll use a yellow again, I guess. We include this extra yellow over here. If I double the sum of the 8 terms, if I use 10 as my first, and so to get the total vertical distance, if we use 10 as our first term, then you need to subtract 10. You need to subtract that extra 10 here. That's added on when you double all those, when you double that. Does that make sense? So I'll give you the same answer. So really quickly, S8 would have been, first term is 10 times common ratio is 0.7 to the power of 8 minus 1 all over 0.7 minus 1. I'm just going to really quickly calculate this. 8 minus 1 divided by 0.7 minus 1, or negative 0.3. Okay, it's going to give you 31.41. And so your total vertical equals 2 times that 31.41, but minus 10. You have to subtract the 10 because you actually included it. So times 2 minus 10, we have an extra 10 in there, and that gives you the same answer, 52.8. Okay, so another method to solving it, just where do you make your first term? I like making my first term the actual after the first bounds, personally, and then adding on that extra 10, but it's really up to you. So you have 2 options. Okay, I'm going to skip number 6 for now. I might go over this on, I'd like to come back to number 6 on maybe Wednesday. Because it's a good question, but I don't think you need to worry about it right now. It's not as, like, impertinent. The tournament question involving the chess players, I'd like to give you some time to work on some stuff today. I know you haven't had much time, and you have a quiz tomorrow, so I will come in. Hopefully I'll be here tomorrow. If I am here tomorrow, I'll be here early. My son is sick as well, so yay. It's just like taking us out. Same with Sweeney and his son. It's just like going through the math department. Chess problem, I'm going to skip. I think we're going to leave it here if that's okay, and let you have some time to work on your homework, okay? So, and then ask questions if you have questions.